Welcome back to Mr. Greenstein's Geometry, and this is Chapter 11, Section 4, Three-Dimensional Figures. Let's first talk about the different types of three-dimensional figures. So we have three-dimensional figures are typically called solids, and solids have what is called faces. So a face is like one of these sides here. It has an edge, and the edge connects the two faces or two faces together. And it also has a vertex, and that's where the edges meet. A polyhedron is a solid that is bounded by polygons. So this is a polyhedron because in each one of these there's a polygon face. There are things that are not polyhedron, and this is a perfect example down here because it has a curved surface. It's half of a cylinder, so it has a curved surface here, and that curved surface makes it not a polyhedron. The types of solids that are polyhedrons, so we have the prism, and the prism has two parallel congruent polygonal bases. So we can consider this part, this top here, to be a base, and then the bottom part here to be a base. And they are congruent, and they are polygons themselves. And bases are connected by parallelogram faces. So you can see here, this is a face that is a parallelogram. It happens to be a rectangle, but it connects the two bases, the base on the top and the base on the bottom. Pyramids, on the other hand, have one polygonal face, and that's at the bottom here, and it has a vertex at the top. The base and the vertex are connected by triangular faces, so you can see the triangles at each one of these faces. Now, to name these things, we name the shape based on the base. So in this top one here, we have a base that's a rectangle, so we call it a rectangular prism. The pyramid on the bottom has a hexagon as a base, so we call it a hexagonal pyramid. The types of solids that are not polyhedron are like the cylinder, and the cylinder has two parallel circular bases, so one base here and one base down here, and they're both circles, and they're connected by curved sides, so there's a curved side in between. A cone, on the other hand, looks like what you would expect like an ice cream cone. It has one circular base down here at the bottom and a vertex at the top, and it's connected by a curved surface here. A sphere is just a surface that is defined by being the same distance from some center. So if I found a center here, the surface of the sphere is all the points that are equidistant from that center. So on a sphere, everything is curved. Cross-section is one way that we can look at a figure, and it's a way of creating a two-dimensional version of the figure by slicing an imaginary plane through it. So if I take this cube here, this blue cube, and slice this sort of salmon-colored or orange-colored piece through it, it's just like cutting it with a knife, I create a square. So you're cutting through the figure. Here, I'm going to cut through the same cube, except I'm going to go at a diagonal, and what it creates is a rectangle. A rectangle. And if I cut it at the edge here, the thing that it will form is a little triangle. So think of this as like a block of cheese. And I take a knife and I just run it through, and then when I look at the surface that I created, I created a rectangle in this case, a triangle in this case. That's cross section. So here are 3 cross sections that you should describe and write down on your paper right now. Moving on, the solid of revolution. So what we're going to do is we're going to create a 3-dimensional figure by taking a 2-dimensional figure and rotating it around some axis. Here's an example. I'm going to take a rectangle and I'm going to rotate it around this axis that's on one side of the rectangle. And as I rotate it around, you'll see that it starts forming a cylinder until finally we have the whole cylinder. So here's an example of a triangle, and what happens if I rotate the triangle around this center here, this edge, and then write that down and draw yourself a little picture on your notes. We will talk about more of this in the upcoming class period.